For today, we're going to be talking about the unit circle. The unit circle is something that we are going to use throughout trigonometry class. So what happens here is you have this big circle, and your starting point is right here, over on the right-hand side. That's where we start, and then it goes around the circle in that direction, so counterclockwise. And there's three different things that happen on this unit circle. You have, if you notice, your degrees, so this little blank for the degrees. And each of those is symbolizing this little dot right here. Then after the degrees, you have a little space, and this one right here is for your radians. We learned a little bit about that at the end of last semester, about pi over 6 and 2 pi over 3. We learned how to convert those. And then lastly, you have on the outside what we call a value. That's going to be an ordered pair. That again symbolizes this point. So each of these three symbolizes that point. These three represent that point. These three represent this point. And it goes that way all around the entire unit circle. So notice at the top, the degrees and radians go on the inside, right? The green and the red. And then the values go on the outside. So one by one, we're just going to fill these in. Let's start with the degrees because it's something that most people are the most comfortable with. You guys spent a lot of time in geometry working on the degrees. All right, so I'll blow this up and then kind of move it around as we go. First, we're going to start with 0 degrees right here. And then if you notice, this circle is comprised of kind of some bigger jumps and then some smaller jumps. So what I mean is from here to here is quite a distance, but then it's a little bit shorter and a little bit shorter. And it kind of just alternates like that, a little bit longer, shorter, shorter, longer. All right. So each of the bigger jumps, the longer jumps, are going to represent a jump of 30 degrees. And each of the smaller ones is going to represent a jump of 15 degrees. So the next one I have here is 30 degrees. That's representing this right there. Then I have 45, 15 more for this guy. 15 more would get me 60. Then I have another long jump, which would add 30 to give me 90 degrees for that point right here. And you can see that this right here is that 90-degree angle. So that's what we mean when we say that this point represents 90 degrees. Let's keep going. We'll keep adding 15 and 30 throughout. Add 30 to the next one to get 120. Small jump, add 15. Small jump, add 15. Big jump, add 30. We'll continue around. Big jump, add 30. Small jump, add 15. Small jump, add 15. So right there, that 204 degrees is symbolizing that point right here. So it'd be the angle from the original line all the way around to that 240 line. Represents your 240 degrees. All right, we'll keep moving. Add 30 for that big jump to get 270 degrees. Another large jump would put us at 300. Then you got a little jump, 315. Another little jump, 330. And then a large jump again to put you at 360. And we know 360 degrees is all the way around the unit circle, all the way around any circle. So we are now back to the beginning. So those are your degrees. Next, we're going to talk about our radians. Now, from at the end of last semester, we actually took these degrees and we converted them over into radians. So let me refresh your memory on how to do that. Let's take 30 degrees down here a little bit. If we have 30 degrees, we are going to convert that into radians by multiplying by pi over 180 degrees. we get 30 pi over 180. And then we reduce the number, the fraction 30 over 180. Both of those can be divided by 30 to get 1 pi, or just pi, over 6. So then on the line next to the 30 degrees, we're going to write pi over 6. That represents that dot right there. So 30 degrees and pi over 6 are the same angle measurement. Now, what we would normally do is do that for every single number around the unit circle. Right? But since we've already done that last semester, since we had that practice, we're just going to go ahead. I'm just going to fill these in with you. But know that that's how we're getting those numbers. So 45 degrees corresponds to pi over 4 radians. That's that point right there. 60 degrees is pi over 3. 90 degrees is pi over 2. 120 degrees, 2 pi over 3. Again, that symbolizes that right there. 135 degrees is 3 pi over 4. That point right there. 150 degrees, 5 pi over 6. That point right there. So you kind of got to be careful. Some of these look like they're a little bit close. So notice this 5 pi over 6. It's kind of close to this dot as well as this dot. So you got to make sure that you're looking at it correctly. It would actually represent this dot right here, not that one. So just be careful as you're learning to read this and see which ones correspond to each other. All right, we'll continue our way around. The next one is 180 degrees. That is just pi. As we work our way around, I get 7 pi over 6 for the 210. 5 pi over 4 for the 225. 4 pi over 3 for the 240. Again, each of those we are getting from converting it. We're just not showing all the work and doing all the process right now. This one would be 3 pi over 2. 300 degrees is 5 pi over 3. 315, 7 pi over 4. And 330, 11 pi over 6. All the way around to the beginning, finishes up with 2 pi. And of course, the very start, which we probably should have done at the very beginning, would have been 0. So 0 degrees corresponds to 0 radians. So far we've taken care of the degrees in green and the radians in red. The next thing we're going to do is fill in the values on the outside of the circle. These are actually the sides of the triangles that are created. So we'll start off with your basic ones. We'll start off here on the right-hand side. I want you to think about this circle as being on a quadrant. This is called the unit circle. Unit represents 1. So when we say this is a unit circle, each point, if you go right or left or up or down, is a distance of 1. So this point over here on the right, 1 in the x direction, 0 in the y direction. On the left-hand side, you would have -1, 0. Up at the top, 0 for the x, 1 for the y. And at the bottom, 0, -1. All right, now we're going to start to fill in all the rest of these inside pieces. The thing about the rest of these are all going to be decimals, but decimals are approximations. So instead of making them decimals, we are going to leave them in a square root form. This first one is the square root of 3 over 2 and 1/2. So if you guys actually took the square root of 3 and divided it by 2, right, square root of 3 over 2, you would get about 0.86. Let me draw for you what that means. I wouldn't draw this on your own unit circle, but I want to draw out what that means. So what I'm doing is the x and the y, the points, are actually the sides of a triangle if you drew it. That triangle right here. So that they're saying this distance on the bottom, x, is about 0.86. But they're calling it square root of 3 over 2. They're being very exact about that length. And then this up and down length here is 1/2, or 0.5, right? That's an exact value, 0.5. And just that's how long the sides of the triangle are. And that comes from some geometry proofs that have to do with the sides in a 30, 60, 90 triangle. So you did it back in geometry. If you want more details about that, I would love to talk to you about it. If not, totally understand that too. All right, the next point, your values are going to be radical 2 over 2 and radical 2 over 2. The square root of 2 over 2 gets you a little bit less. It gets you about 0.7. About 0.7. So if you notice, this triangle is a little bit shorter. Doesn't extend quite out as far as the other one. And just a little bit taller. So a little bit long, a little bit shorter than the 0.86, but a little bit taller than the 1/2 that we had. So we're saying that this side is about 0.7 and that side is about 0.7. 0.7 is that radical 2 over 2. And there's your triangle. So that's where those numbers are coming from. We don't have to worry about proving that or showing that at all, but I just wanted to give you guys a little bit of background so you know that I'm not just making these numbers up. Now, this last point right here is actually this first point, but flipped around. The x becomes the y becomes the x. So those are nice because those two are just the same, but flipped around. Now, the good news, everything else around this circle is very symmetric. So what we're going to do is just kind of line everything up. So this first dot here, if you look over, kind of matches up with that one. That means that these numbers are going to be the same. The only difference is going to be our signs, positive versus negative. So think about this again as the center. If you go forward, it's positive. If you go up, it's positive. If you go left, it's negative. If you go down, it's negative. So when I'm trying to get to this point right here, I'm going to go left, negative, but up, positive. So the same values, just a slightly different sign. And everything in this quadrant up here is going to be going to the left and up. So the x will be negative and the y will be positive. Okay. Let's get moving out of this bottom area. These correspond top to bottom as well. So this one right here mirror images that to right here. So you're going to have that same repeating, but notice where this point is. From the center, it was left and down, both negative. So your x's and y's would both be negative. And then you're just going to copy the rest of those over, making both the x and the y a negative. Right, we have this last quadrant. Notice here, in order to get to this quadrant down here, you're going forwards So x is positive, and then down, y is negative. So just trace each of these over. Those are going to be the same values, because now I have a positive in the x and a negative in the y. Positive in the x, negative in the y. All right, let's take a look at that. Looks like we've got a pretty symmetric graph here. All of our numbers look like they're lining up across from each other, one on top of the other. It looks pretty good here. All right, so there's a little bit more information I want to give you on this part. Around the outside, I want us to label our quadrants. Sorry about that. This first quadrant here in the upper right-hand corner is what we're going to call quadrant 1. Over here, quadrant 2. Down here, quadrant 3. And over here, quadrant 4. Sometimes you may see these as Roman numerals. Roman numerals for 1, 2, 3, and 4 would look like this. 1, 2, 3, and 4. Or without the lines at the top, 1, 2, 3, and 4. Right. So 1, 2, 3 is pretty obvious, and then 4 is just that other one. Okay. So make sure you have those quadrants labeled. Then we've got one final thing to do. We're going to talk about sine and cosine, but instead of talking about them in terms of O, A, and H like we have been, we're going to talk about them in terms of X and Y like we would do on this circle. So I'm going to write each of these out for us. All right, so the first is sine. Sine, anytime we're talking about the unit circle, is just X. And that's because the hypotenuse is always going to be 1. And so when you divide by 1, you just get the value at the top. And in this case, that's X. Cosine is Y. Oops, excuse me, I messed that up. Apologies. All right, here we go. Let's try that again. Sine is Y. Cosine is X. And tangent is Y over X. Thanks for being patient as I corrected my mistake. Then cosecant is 1 over Y. Remember that these two are always kind of paired up with each other, right? So they're always the reciprocal of each other. And then secant is 1 over X. And cotangent is X over Y. And I want you to remember that these are always paired up. They're always the reciprocal of each other. So always write those kind of as little pairs. All right, I know that was quite a lot of information. Feel free to watch that video again if you need, or rewind back to certain places. And if you have questions, let me know. We will work with this circle a lot. So if you need anything, I'm happy to help. Really nice job today.